Hello everyone, this is Peter Online Computer Network Engineering Tutorial. I'm here to present to you, spanning tree protocol, okay, part 2. And I want to tell you how switches select the root switch. The root switch is the head of switch, okay, that, sends messages to every other switches. And this message is called bridge protocol data unit. Okay, so it's in the network switch network environment. Loop is bound to occur. Okay, loop is bound to occur. Loop is the multiple copies of a frame sent by a particular computer. Okay, in the means of app or broadcast. Okay, so the multiple copies of it can grant the network. Okay, it can occupy the bandwidth or the memory or processing speed of switch, thereby bringing the network down. So in order to prevent such thing, there's something called spanning tree protocol, and I've taught this before, but we are here now to talk about how switches select the root bridge. They will start, in order to prevent loop, the first step is to selecting the head of the switch, which will be sending message. Message cannot be sent anyhow, no. So now look at these switches has bridge ID and MAC addresses. Okay, they have bridge IDs. Now they will send a bridge protocol data unit like a hello message. Okay, in order to do this, a kind of election has to be happening here, and the switch with the lowest bridge priority number will win the election. Okay, so they start by campaigning. This switch here send a message and say, here is my bridge ID. This is this, which is this. And this receives it and compare the bridge ID with its own and see that it has the lower bridge ID. Okay, now, because this believe that it is the root bridge. Now, this sent again, and this receives it, the other two receives it and compare their bridge IDs. Okay, and see that if this bridge priority that is the same number with its own. So it prepared to send another message. But when this switch sent and this receives it and discover that the bridge ID is lower, this switch stops sending message. And this receive the same thing happened here. So automatically this switch wins, switch one wins the election. If they now reroute bridge. So traffic will be sending from this link to the other switches. Okay. So now let's say now this is the root switch or root bridge. Okay. So now they need to determine root port. Root port is the port that is close to root bridge, because this port here is in the forwarding state. This port will be placed in the forwarding state because it's the root bridge. And this port now, these ports, for them to determine other ports that will be in forwarding state, there's something called root cost. Okay, root cost. From this root, this switch sees its root as 0 because it's the bridge ID, and this here is 0. This root cost here, root cost, it will cost this to reach the root bridge 5. Okay, now 0 plus 5 is equals to 5. That is from this root. Okay, from this root, this is 4. Any gigabit interface is 4. If it is a fast Ethernet, that's 100 megabit Ethernet, it will be 100. So now, from here to here is 4. So now, this here will be in forwarding state, root port, will be in forwarding state, because here is 4 and here is 4. So for this, 4 plus 4 is 8. So the lowest root cost will be in forwarding state. So this is the lowest here, and this is the second lowest in the forwarding state. Now they need to determine, the interface to block, because one link must be blocked. They don't want message to go anyhow. Messages will be going in one direction to avoid loop, to ensure loop free. So now they have to compare their bridge IDs. This switch bridge ID is this switch bridge ID is this. If these two bridge ID are the same, they may compare their port numbers, and they see that this port number is higher. So the lower port number wins the root designated port, DP. So this has to be in forwarding state, okay? And this is in the blocking state. This is called designated port. Designated port. This is root port and this is root bridge. So to ensure designated root port, in root port, okay, has to be in forwarding state. Okay, designated port need to be in forwarding state. I think alternate port is this that is blocked. So for computer here to receive message from computer here, traffic need to go through this way and get to this computer. So it can't come here because here is blocked. So information will be going here and stop here, can come here and stop here. It can to avoid that loop free. Okay, so that is how it happens. STP uses, and in the next tutorial, we are going to talk about rapid spanning tree protocol. Thank you. I'll see you in the next tutorial. If you like this video, go ahead and share it. Thank you.